welcome to day 20 out of 22. We're almost there. Today we're going to talk about univariate statistics. What you first see on your notes page and on the screen are all the different terms and symbols for what we will be talking about for our univariate stats unit or lesson. Now, univariate means one variable. Like unicycle, one, varia as in variable. So it's one variable statistics. So we have the mean, which is what you would consider the average. Add up all the scores, divide by the total number of scores, and you have your mean. And that has a symbol with the X with the bar over it. That's the symbol for the mean. Mean, median, and mode are the three common measures of center that you may know. Mean is your average. The median is the middle number. It's the midpoint of an ordered list of data. Half the values are at or below that number, and the other half are either equal to or above that number. There is no symbol for median, so we just abbreviate it MED. And mode rhymes with most. Mode and most sound the same. Mode is the value that occurs most frequently. It's the most common score. Minimum, exactly what you might guess, is the lowest number in the data set. Quartile 1, also represented by Q sub 1, Q1, that is the number that's exactly in the middle of the minimum and the median. So that is the 25th, it's also called the 25th percentile score, because 25% or 1/4 of the numbers are at or below that. Now the upper end, the 75th percentile score, that's Q3, that's called the upper quartile. So quartile 3, also known as the upper quartile, that is the value where 75% of the scores are either equal to or below. Q1 is also called the lower quartile. So the lower quartile is exactly halfway between the lowest number and the middle number, the median. The upper quartile is exactly halfway between the median and the highest value, which is called the maximum. Makes sense that the maximum number in your list is called the maximum. Lowest number in your list is called the minimum. Now there are three different types of measuring variability. That means the spread of scores, or how much variety is in your data set. Variability, variety. One, to measure the spread or how close together the scores are, you can do the range. That's when you do the maximum number in your list minus the minimum number. Max minus the min. That's called the range. If you did the interquartile range, you're subtracting the quartiles. The upper quartile minus the lower quartile. And then something that's called the standard deviation. That is a number used to determine how far a data point is away from the mean. So it helps us determine whether the big picture of scores or data sets are close together, clumped close together, or if they're really spread out. Okay, so that's the standard deviation. And then an outlier is something that lies out far away from most of the data set. It's an extreme high score or an extreme low score that seems to not quite fit the pattern of the data because it's too high or too low. Okay? Now, these vocab words can be grouped by different types of descriptions. In other words, they're telling us different things about our data set. Our measures of center, that's the mean, median, and mode. Those are the ones that give us specific information. It's a single number that gives us information about the data set. The measures of spread refers to the variability. Now, variability, as I said before, is talked about how spread out the data set are. Okay, whether the numbers are grouped very close together or whether they're very spread out. But within those measures of spread, we have to be careful about looking at outliers. And then the third is the 5-number summary. This is when the data is broken down into quarters, each one 25% of the data. We got our lowest score and our highest score, and then the 5-number summary, the values in between, split the data into 4 equally sized sections, and it tells us what those cutoffs are. And we'll get into that over the next half hour or so. So let's start with some basic stuff. Given a set of numbers, find each of the following. So here's our set of numbers. Got bumped to the next page. 60, 70, 75, 76, 77, 80, 82, 84, 86, 89, 90, 92, 92, 95, 97. So let's find the mean. So get your calculator out. What I want you to do is add up all these numbers and divide by however many there are. So let's do a quick count and figure out how many numbers we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 numbers. Total numbers in our list, there's 15 of them. So you're going to add these up, divide by 15, and then come back. So I want you to pause it, find the mean, and then unpause it, and we'll see how you did. So when we add them all up, we get 1,250. So to do our mean, we take that 1,250, which is the sum of all the scores, divide it by the fact that there were 15 scores, and that gives us our average of 83.333 repeating. The symbol was X with the bar over it, so there's our average. Our minimum, the lowest number in our data set, the lowest number in our list is a 65. The highest number, our maximum, is 97. And then the middle number. To find the middle number, which is our median, what we can do is just count in from each end, one at a time, until we get to the one number that is exactly in the middle. If there ends up 2 of them, I just average them. So our median is 84. So if our median is 84, now we have to find Q1, the lower quartile. So we count in from each end, from the midpoint, from the median of 84, and from the minimum of 65, we have to find the score that's in the middle of those. So without counting the median, I go the same process that I found the median. I'm going to count in from each end, from the minimum and from the median. Count in to find the middle of the minimum and the median to get my Q1 of 76. Now I'm going to do that same process at the upper end to get my Q3, my upper quartile value. I do not use the median, just the number next to it to start with, and keep counting until I get the middle. And that is my 5-number summary. That's the 5-number summary. Those are the 5 numbers. Minimum, Q1 or lower quartile, median, which is the exact middle, Q3, which is the upper quartile, and then the maximum. Now, population standard deviation and the sample standard deviation have different symbols, but they're going to have similar numbers. So the population standard deviation is the one that looks like a circle with a little squiggly at the top, almost like a cherry or maybe a bomb from an old cartoon. That, I'm reading from my calculator, is 9.11897. Now, you're not going to have to worry about how to find it because the calculator does it for you. You just need to know what symbol to look for when I tell you to find the population standard deviation, or maybe the sample standard deviation. Now, the sample standard deviation is easy to notice because the symbol is an S, S for sample. And that value is 9.4390. So the difference between population standard deviation and sample standard deviation, the calculator will take every single number in the data set and do the standard deviation calculation. It tells us that on average, the data numbers are 9.1 away from the mean of 83. So the average distance that the actual score is away from our average is 9.11. The sample standard deviation doesn't use every single data point. That's why they're a little bit different. But you just need to recognize which one's which by their symbols and be able to point those out. All right. Our mode. Mode is which number showed up most often. So what score showed up most? And if you didn't cross off all your numbers and you can still read them, you can see that the number 92 is the only one that showed up more than once. That is our mode. If you have more than one mode, that's totally okay. It is also possible to have no modes. If every number shows up the same amount of times, you have no most used number. So that would be no mode. Okay, the range. That's when you take the highest number and subtract out the lowest number. So in this case, our highest number, our max is 97. We're going to subtract out 65. So use your calculator if you have to, but what you're going to do is do 97 minus 65, and you're going to get a range of 32. The IQR interquartile range, that's when you subtract the upper quartile score, Q3, minus the Q1. That means in this case we're doing 92 minus 76. And if you go to your calculator and do 92 minus 76, you'll get that the interquartile range is 16. So that's how we do some of these, recognize some of these. For example, number 2, given the frequency table and the one variable statistics that came from the data in that table, find the following. So what I'm giving you is the actual scores. The score of 68 occurred 3 times. That's what frequency means, how many times did that score show up in the list. So there were 3 scores of 68, 10 scores of 75, 3 scores of 82, 2 scores of 88, and 6 scores of 93. In order to find your mean, you would do 68 plus 68 plus 68, 3 of them, and then 75 plus 75 plus 75 plus 75. So 10 of those. You would type in 3 of the 82s, 2 of the 88s, and 6 of the 93s. Add them all up and divide by the total number of scores, and you would get your average, your mean. So what I'm testing here is I'm checking to see if you were awake and looking and noticing and can pick out which symbols go with which values. And now that you know what frequency means, if you can answer what's the middle number and what's the mode. So I want you to pause the video, take some time to answer and find all these values based on the information that I gave in the table, and then unpause the video and we'll check and see how you did. And bam, here we go. So our mean, our average, 81.2, given at the top of the table where the calculator values were shown. Our minimum is the min, 68. Q1 is the Q1, 71.5. The median is the median is 82. Q3 is the Q3, 90.5. Maximum is the max, 93. The population is the O with the little squiggle on top, a cowlick, like a hair sticking up on the top of its head. That's the 8.93085. In the sample standard deviation, which is the S of X, that's the 9.98499. Mode, which score occurred most often? Which score has the highest frequency? Well, there were 10 scores of 75, so there's our mode. Range is when you do the highest minus the lowest, max minus min. So a 93 minus 68 is 25. And then the interquartile range, that's what IQR stands for, interquartile range. That's Q3 minus Q1, so 90.5 minus 71.5 is 19. All right, next for our one variable statistics, the 5-number summary, minimum, Q1, median, Q3, maximum, is oftentimes used to create a box plot. So a box plot shows the 5-number summary, and the 5-number summary is used to make a box plot. So the numbers go in order from left to right. Always go small values to high values, low to high. And then each time there is a score, one of your numbers from your 5-number summary, there is a vertical line on the box plot. So the very first line at the far left, that is your minimum value. In this case, that would be 55. The next vertical line in your box and whisker plot is the start of the box. That's going to be the lower quartile, or the Q1. So in this case, that's the 70. The next line after that, the one that's exactly in the middle, is the median. So in this case, our median is 75. The other end of the box, which is why they call it a box plot, that's Q3, the upper quartile. So in this case, that is an 85. And the last vertical line on the graph is the maximum value. So in this case, that is 100. So once you know your 5-number summary, you can put a vertical line at each of those numbers, box in the middle, and then put what they call whiskers, or lines at the ends, to go down to the minimum and then up to the maximum. If the box plot is already given, then you just read where the vertical lines are, or in the next example you'll see dots. And those 5 vertical lines, or those key points on the graph, lowest value, start of the box, middle is median, the other end of the box, and highest, that's your 5-number summary. So pause the video, write out the numbers for the 5-number summary for this, and then answer some questions, and then start it back up, and we'll see how you did. So pause it, do it, and then come back. So here are your 5-number summary scores. The minimum, the lowest value, is exactly in between 70 and 72. That's why it's 71. The beginning of the box is the Q1, lower quartile. Quartile 1 score is 75 because it's exactly in between 74 and 76. Our median, the middle dash, the middle line, the middle value is 78. Upper quartile, the end of the box, is 82. And the highest, all the way at the end, maximum value is 87. So now find the range, find the interquartile range, and then come back. So pause it if you haven't yet, find the range and interquartile range, and then come back. So our range is when you take the maximum number minus the minimum number. So 87 minus 71 is 16. And the interquartile range is when you subtract the two quartile scores that you know, 82 minus 75. So based on the box plot, 50%, half of the people, were taller than what height? Well, half the people, the middle number, that's our median score. The median value is 78, in this case inches for our units. So half the people are taller than 78 inches. And that is our median. Median is the exact middle score. So half are either at that height or below, and the other half are either at that height or above. So that's our middle number. What percentage of the players are taller than 75 inches? Percent of the players. So the 75 is our lower quartile score. That's Q1. That is our 25th percentile. Now, percentile scores measure the percentage of people at or below a certain value. So if Q1 is at 75, that means that 25% of players or people are at or below 75 inches. But this asks what percentage of people are taller than 75 inches. So if 25% of the people are below 75 inches, then 75% of the people are taller. So 25% of the people are below, because that is exactly what the Q1 score tells us. Okay, Q1, the first quarter, 1/4 is 25 cents, which is 25%. So 1/4 of the people are 75 inches or shorter. That means 3/4 of the people, or 75%, are taller than 75 inches. Inches, not inches. All right, we're doing well, doing well. Next type of graph, histograms. Histograms and dot plots. So data tells a story, and numerical data is often summarized by graphs. One of the graphs we just saw was the box and whisker plot. That helps show us whether the scores are clumped close together or whether they're spread out. Graphs provide a representation of data distribution and are used to understand the data to answer questions about the distribution. So there are two types of graph we're going to focus on right now, the dot plots and the histograms. A dot plot is a plot of each data value on a scale or number line. So a dot plot shows every single score. The histogram is a bar graph that groups the data into intervals. Now, one thing that's different between a histogram and just a generic bar graph, a histogram has to have the bars touching. And a regular generic bar graph does not have to have the bars touching. So that's what makes a bar graph into a histogram, is if the bars touch. So if you're asked to find or locate or draw a histogram, make sure the bars touch. The height of the bars, when you make a histogram, represents the frequency of the data values that are in that interval. So when you do a bar graph or a dot plot, what we see is how many of each score, or how many of the numbers fall within a range of scores. So it's a graph that shows how many data points are in either an exact value or in a range. When this is plotted, we can get different types of graphs, lots of different types of graphs. Some of them have actual names. So if something is symmetric, that means it's balanced and even on the left and on the right. Symmetry. So it's the same. You could find a peak, the highest point, and it looks pretty much the same on both sides. It doesn't have to be perfectly the same on both sides, but if it's pretty close, then it's called symmetric. In a dot plot, you can see nice, even hill around one or two equal or close to equal highest points in the middle. That's symmetric. It could also be skewed. Skewed means sloped or slanted. So we have an example that's skewed to the right because it's slanted or stretched to the right. So skewed means stretched or slanted or pulled. It's unlevel. Or we could have it skewed left. This one's stretched to the left. So whichever way it's pulled or extended, that's the skew. So the blue one is skewed right because it's pulled to the right. And then the greenish one is skewed left because it's pulled or stretched to the left. When you have distributions like this, you can talk about the measures of center, the spread, the peaks, outliers, or clusters. So mean, median, or mode, those are located in slightly different positions in these graphs. Hard to tell sometimes where exactly they are, especially the mean, because if you're dealing with a histogram that has intervals, you do not have all of the exact data points, so you can't find the mean. But the mean is the balance point, okay, the center, the balance center of the graph. The median is the number that's exactly in the middle, and the mode would be whichever number occurs the most. You can see the mode most easily because it's where the peaks are. The peak is just what it sounds like, the peak of a mountain, the highest point. The spread refers to how spread out the data is. This is also called variability. An outlier would be one or two scores that extremely stick out away from everybody else, from the other data sets. And cluster is like a grouping, like a cluster of stars, just a group of stars. All right, so let's describe the shape, center, and spread of the data sets below. So this first one, if we notice, we kind of trace along the top. This is stretched or pulled down to the left. So this is skewed left. Okay. The center, if you think about trying to balance this on your finger, the center would probably somewhere be around 5. Now, because this is a dot plot, we could find the actual mean. We can find the median because we could do the middle number, and we can find the mode. So we have 1 9, 1 2 3 4 5 8s, 6 7s, 3 6s, 2 5s, 2 4s, and 1 3 1 2 1 1. So let's find the middle value. We can do that the same way we did with the data set with the numbers. We can just count in from each side. 1 2 3 4 5 6 7 8 9 10 dots. 1 2 3 4 5 6 7 8 9 10 dots. 11 11. So our measure of center, the median, the exact middle number, is at 7. Our mode, the number that shows up most often, most frequently, is where the peak occurs, which is at 7. And then the spread of the data, our range, max minus min, 9 minus 1, is 8. All right, so let's look at the next two graphs. How is this skewed? That one's skewed left, and the other one's skewed right. Now, we don't have any numbers here, but your mean would be the balance point. So it'll be somewhere near where you would try to cut this out and balance it on your finger on the tip of a pen. But we have skewed left because it's stretched to the left, skewed right, stretched to the right. Okay, let's actually do a dot plot ourselves, then we'll do a histogram ourselves, and then we're done. So here we go. A random sample of teenagers ages 13 to 14 were asked, on average, how many text messages do you send per day? Here are the results. 0, 10, 10, 10, 10, 20, 20, 20, 30, 40, 40, 50, 70, 80, 100. Display the data in a dot plot, and then what can you say about the results? That's what these extra questions are for at the bottom. So here we go. There's a score of 0, so we put a dot at 0. 1, 2, 3, 4 10s. So we're trying to put these evenly spaced, and 1 dot on the graph for every times that number showed up. 20, 20, 20. 3 20s. 130. 2 40s. 150. 170. 180. 100. So where's the approximate center? Well, if we go back to our median, 1 2 3 4 5 6 from that end, 1 2 3 4 5 6 from that end. Approximate center right around the 20. So we have the same number of dots on both sides. The peak. The peak is the same thing as the mode. Which number shows up the most? That was the 10. Outliers would be a score that's really high compared to everything else, or really low compared to everything else. So this 100 kind of stands out. It's separated from the rest of the data, so we'll call that our outlier here. Sometimes there just isn't one, guys, and that's okay too. The range is the max minus the min. Our max is 100 and our min is 0, so our range is also 100. So this is pretty widespread because we see numbers a lot in the 10s and 20s, a little group over here in the 40s, but we also have a bunch of numbers 70, 80, and 100. So this is a large spread because the numbers are spread out across a lot of values, a large range. describe the shape? Well, if we were to try to trace this like we were doing some of the other examples, this would be pulled or skewed to the right. Give a range of numbers where the data is clustered. So a cluster is like a grouping of numbers packed together. There's a nice little cluster right around 10 to 20. There's also a small cluster around 40, but there's a bigger grouping, so that's where we're going to put our cluster. Gaps would be like a space in between data sets, in between data numbers. So there's a gap from 50 to 70. And because R100 is an outlier, we don't consider that a gap. But because there's 2 data points after the 50 before the outlier, there's a gap that jumps from 50 to 70. And then there is more than 1 data point there. If there's a space between a group of data and 1 number, and only 1 number, that's more like an outlier. So our gap is from 50 to 70. So that's how you do a dot plot, how you can read a dot plot. Now we're going to do a histogram. So to do our histogram, and this is a data of 20 students and a teacher in a math class, and they were surveyed to see how many times a week they spent in the math department instruction center. So how many minutes a week they spend getting extra help. So first thing we're going to do is put our data into our table. So we can just use chicken scratches, tally marks. 0 is in the range 0 to 9. 10 is in the range 10 to 19. 28 is in the range 20 to 29. 30 is in the range 30 to 39. And then a 15, an 18, 55, 25, 15, 10, 40, 5, 25, 12, 15, 50, 0, 20, 10, and 40. Now, it's said that we have 20 students. I want to make sure that I have 20 tally marks. So 1, 2, 3. 5 is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 tally marks. Good. So now let's total up our tally marks. We have 3 in the range from 0 to 9, 8 in the range from 10 to 19, 4 in the range from 20 to 29, and then 1, 2, 2 for the others. All right, so we have 1, 2, 3, 4, 5, 6 intervals to put across the bottom, the x-axis. So our intervals go along the x-axis, and our frequency goes along the y-axis. So the frequency is how many times there was a score within the interval that was given to us. So we have 6 intervals, and our intervals have to be the same size across the bottom of our graph. So let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20 boxes divided by 6, and I need it to come out to be a whole number so that every interval is the same width. That means they will all be 3 boxes wide. 3 squares. 3 squares wide, and I should have enough to fit my 6 intervals. The intervals are 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. And they all are the same width, and they all fit. Next, the frequency. My highest frequency is 8, so I need to make sure I can count up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And now I make my box plot with the bars touching, turning it into a histogram. So from 0 to 9, frequency is 3. From 10 to 19, frequency is 8. From 20 to 29, frequency is 4. 30 to 39, frequency is 1. 40 to 49, frequency is 2. 50 to 59, frequency is 2. I know a lot of people like to color in their bars. You're totally welcome to do that, but you do not have to. That is not necessary. That is not a requirement. Okay, that is not part of the grading. Being able to color within the lines is fantastic, but that is more of an elementary thing, not a high school algebra thing. So we are done. 35 minutes. I hope you weren't too bored and stayed awake the whole time. And one more lesson till the end of summer school. Have a good day. Talk to you later.